Exercise 06 is going to have us implement the power function. So we are going to raise x to the power y from the main using a function named POW. So, well, there is a routine now that we are getting used to. Our function POW is going to accept two positive integers, int a and int b. Okay, so I first add here its prototype in tools.h. Then go to tools.c, where I'm going to actually implement the function. So let's go to the end of our file. We're going to have here int POW, int a, int b. And we are going to, well, let's use command starting thing here. I'm going to test if a and b are both positive or null, and if not, return 0. And after that, well, for now, I will return 0, let's say 42. It's even better to trigger test on S. I'm going to return to 42 because I didn't implement yet my function. Okay, now back to the main. Same code is going to be used here, same code pattern, okay? And I'm going to replace this function not yet implemented piece of code right now by calling the appropriate function. And we have completed the three functions that we set initially to implement. So instead of GCD, we are going to call POW and display the result of calling POW function. And there you go. So the main is ready to call our function on demand. I will have to test that, of course. We implemented a shell, an empty shell for our function. We'll come back to that in a second. We have here the prototype for the function, and we need to take care of test.c. So in test.c, I will have once again test the POW function, which means I'm going to need a prototype for test POW, prototype for test POW single case, and then I'm going to implement them. So let me go to the end of my file, and I'm going to have a void test POW. I should have cut and pasted that. Inside of which I'm going to call test POW case, and let's see what the assignment gives us as case. Well, we have 2.9, which expects 512 as answer, 3.3, 27, 30, 1, minus 1, 3, minus 1. So let's get started with those. And as we need, we'll add more tests as necessary. So we have a 2.9 with expected outcome of 512. We have a test POW case here with 3.3 expected outcome 27. Semicolon. Then we have a 20 with a power of 0, something which gives us, of course, 1. And then we have test POW case of, well, then we have all the cases, and I'm going to be lazy once again, all the cases that test one or both of the parameters being negative, which I'm going to borrow from the LCM test, which I borrowed already from above. So let's see, GCD, test LCM. I was just double checking that I didn't left an error out in my previous implementation. Okay, let me double check this real quick. Test LCM here, test GCD case. No, it's all good. Okay, so we have now our test for the POW function. We need to go ahead and test the cases one by one of our POW function. Actually, I should have taken the latest code, even though they are normally identical. Let's see. test LCM case becomes test POW case. We obtain those results by calling POW function, and then we compare expected with observed, and that should be it. So the last thing we have to do, really, I'm going to give it a compilation real quick, just to make sure I don't leave plenty of syntax error behind. No, it's working. What we have to do really is to play with it interactively. So that's going to require me to compile tools and main, and then run the resulting executable. Let's do just a couple of them by hand to make sure the menu is behaving properly. I'm going to set new values. My value is going to be 2 and 9. And I'm going to compute x power y, which is going to give me POW of 29 equal 42. Well, that's what my code is returning right now. So it's going to just return 42 to everything I try. I forgot about that, so it's not even worth going further. What is worth doing, though, is recompiling with the test, executing, so that we see all the tests that we have right now. 2, 9, 3, 3, 20, 0 with, and I realize that I'm writing LCM here, this is not good, and the difference between observed and expected value. Let me go back actually to test.c, because there are a couple of things here that are not satisfactory. Test POW case -1, yes, it is satisfactory because our version currently still detects errors. It doesn't do much else, but it detects errors. So the only thing really I need to change is here, instead of having LCM, I need to have POW. Let me see, anything else? No. Save. Go back to Conqueror, and real quick, compiles, run. This is better. Okay, now we are going to go back to tools.c, and we are going to write actually the code for our POW function. Okay, what is the deal with POW? We want to elevate a to the power b. So if b is equal to 0, well, the result is going to be 1. Okay, we know that much. So we could like even read this out as a test. If b equal 0, then return 1. Makes our code simpler. We get rid of all the trivial situations we can encounter. Now, if b is at least 1, what we need to do is to keep multiplying a by itself as many times as b times. So we can do that with a loop. Here is my result variable. Result is going to be equal to 1 to start off with. Do while, I'm going to complete the while condition later. This is my do while loop. What am I going to do at each iteration? Well, I'm going to say result is multiplied by, so I'm using a shorthand assignment operator here, is multiplied by the value of a. So I keep multiplying, oops, I'm doing something really, really stupid here. I keep multiplying result by, no, that's correct, by a. So the first iteration result is 1. I multiply it by a. So this is the equivalent of saying I just elevated a to the power 1. Then next iteration, I'm going to go back here and I'm going to say result, which is equal to 1, is again multiplied by a. So now I have square. And I'm going to keep going. Well, I need to keep track of how many times I'm going, and this is going to be given to me by b. Every time I do this, I decrement b by 1. So if b is equal to 1, let's see what I have. Result is 1. Result is multiplied by a. Result is a. b is equal to 0. I did it once. I should stop. So while b is greater strict than 0, I keep iterating. When b reaches 0, I am done. Let's try to see how this works. And let's keep an eye open for the off by 1 problem. Instead of return 42 as well, I'm going to return the result value. And this should round up our little function. Let's try compiling. Syntactically, we're correct. Let's try executing. We pass all the tests. So pretty much we have, assuming our test honest is valid, which I really encourage you to double check that by yourself, that is try to figure out if we have cases that we left out. If our test honest is valid, then we have here a valid implementation of the power function. So let me put it back on the screen, and we will be done with this exercise.